10 p.m. Whoever is interested, we will move to Diego Bar, which is across the street. And if you are interested about speaking at the next Kotlin meetup, let me know. Here is my email. We are always looking for speakers. It can be even something shorter, like a lightning talk, 5 minutes. Don't be afraid to share your knowledge. So for the talks, for Q&A, we will use Slido. It's a system where you can ask questions on your phone and the speaker will answer them at the end of the talk. So you can go to slido.do on your phone and enter hashtag socks, and this way you connect to this event. And that's it for me. And I would like to introduce Wolfram, our guest speaker from Germany.
Okay, everybody, I think you need this. Okay, and I have to switch here to this one. Okay, so I'm going to talk about Kotlin DSLs. And the first question obviously is what actually are domain-specific languages? And as the name of domain-specific languages suggests, it's something that has to do with a specific problem. So when we talk about domains, normally we have some business domain in mind, like accounting or, I don't know, banking or whatever. In this case, the domain is usually much, much smaller. It's normally something technically, it's like creating a user interface or like answering to the Google Assistant or something like that. So that's, but that is the domain we are dealing with, and for this we are creating a specific language. And when you're writing code, whenever you're writing code, whether you want it or not want to write code, you want to write code, but whether you want to do writing APIs or not, you always write APIs. So you have some module or some package or whatever, and you expose some public members from there. These are part of your API. And it's always best to do this explicitly and on purpose than just by doing it implicitly and just creating a haphazard API. So the DSLs are part of the API you are creating, and as such you should also consider about what you're doing. Well, you should always consider about what you're doing, but consider it in the context of creating an API. So there are domain-specific languages have been around for quite a long time. For example, Makefiles for those old or current C code, for example, are DSLs. SQL is DSLs, and many others. And for example, when we build Android apps, the Gradle system that we're using there is has a DSL as well, either a Groovy-based DSL or a Kotlin-based DSL. So these are external DSLs. You're writing them in whatever editor, and they are not really part of the language that you're writing the rest of your code with. And in contrast to that, we have internal DSLs that are written in the host language. So in our case, it's Kotlin DSLs, so we're using Kotlin for that. It's just normal Kotlin code whenever you see a Kotlin DSL. So, and within the DSL parts, you can also use normal Kotlin code, which comes in handy at some points. I will show some examples later. And it uses just normal language constructs, and by combining them in a nice way, let's put it like that, you are able to construct DSL. So first, let's see some samples. So Corin is a dependency injection service locator, whatever framework that allows you to get your dependencies in your code. And Corin works by creating where you can create multiple modules, and this is a definition of a sample module. And you have these keywords here, module and single and factory, and just by looking at it, you can understand, okay, I'm creating a module and it consists of 5 different types that I'm providing to the rest of the app, and 4 of those are singletons, and 1 has to be created whenever I need this dependency. So I think that it's pretty obvious what's going on here, and that's the key point in my opinion. Also with Anko, that is a way to write the user interface in Kotlin, and instead of using XML, you can use this DSL to create your user interface. I personally am not using it. I still like XML, but we eventually all will use this kind of stuff because Kotlin Jetpack Compose is also just another DSL. And finally, Kotlin Test, that's one of my most important libraries that I use daily for testing my app. And the braces are somehow mingled. I'm not sure if they are correct. But it allows you to structure your test code. And you can read what the test is doing. And here, this is where the test code goes. Yeah. So in this case, I have 2 test methods. And when something fails, I get this code string. When the user enters credentials, the app should enable the login button, print it out to the console, and I know which test failed. And by this, I can structure them, and as you can see, I can nest them on different levels. And well, I will show some samples where we will go into some of these constructs, how they are done. And I really like this for readability of tests because, in my opinion, and this whole thing is called a should spec, test should be a specification for the code you're writing. And if you happen to believe in that as well, then Kotlin Test is really a great library to achieve that. So what all these samples had in common is that they are easily readable and that they make the intention of what you're writing pretty obvious. So when you return later on to your code, or when your colleague has to take over or whatever, it's really just gleanable what the user wanted to do. And if you have to switch, for example, from single to factory in Coin, well, you know very easily where to do that. So I already mentioned that DSLs are part of the overall API, and as such, you have to kind of design them. You always have to design APIs, and the same applies to DSLs. And when you think about designing your API, that's something that someone else uses. You can think of it from your own side. You're the provider of the API, or from the consumer side, the client that uses the API. And you should always approach designing APIs with the client in mind. So it's not your job to make your life easier. It's your job to make the life of the others easier. So when someone else wants to use your library or just part, your module, what you're creating or whatever, then it's your job to make it easy for the client to make use of your stuff. And the most important parts are the last two lines here. First of all, the usage should be easy. That's one thing. But the other thing is equally important, that the misuse should be hard. So that the user, maybe especially if it's intuitive, it could be easy to do things wrong. And you should prevent that in the language by, for example, making the compiler balk at that, for example. And that's not something I came up with. There is a very old talk by Joshua Bloch about designing APIs in general, and he stated those. And I think they are really important aspects that you should keep in mind when you're writing any API. So when you're doing something and designing something, you're bound to get it wrong. So we all get it wrong all the time. There's nothing wrong with getting it wrong. It's just life. So very clever people get it wrong all the time. So here's an example from the Java library. Okay, Java, old stuff, but never mind, nevertheless. So they had the date API, the date object from Java 1.0. That was 1997. So with Java 1.1, right, the next version, they deprecated nearly all the methods of the date object and said, oh, Jesus, don't use them, use calendar instead. And calendar was still flawed. You had, for example, a 0-based month, but a 1-based day of the month. So you totally unintuitive, and it was a violation of this one here, because misuse was really, really easy with the calendar object, and it happened all the time. And these were actually bugs that were not so easy to track, because everything worked, it compiled, it ran, but it didn't do what you wanted to. So, okay, over the time, we had plenty of time, we learned about this, but initially it was really horrible. And nearly 20 years later, they finally came up with something that really works, the datetime API in Java 8. And well, if some clever committees are getting it wrong, there's nothing to be shameful of when we get something wrong. So, but what the Java people did wrong, in my opinion, they did plenty of things wrong, so obviously. In hindsight, it's easy to say. But one thing is they tried to keep the old stuff alive for all the time. So they deprecated lots of stuff. I mentioned it, date, in 1.1. Everything was deprecated, but it was never switched off. Everything was still there. And that's horrible, because you still can misuse it, obviously. And you have to look up what to use and whatever. So when you do something and design something, in my opinion, you should never fear to introduce breaking changes. Of course, follow this. For example, if you're doing a library, you should follow this version convention. So don't do it in a 1.0.1, but change the first digit, because you're really breaking that stuff. Then you have to change the first digit, in my opinion. But you shouldn't refrain from that. So that all was general API stuff. There are some things that are specific to DSLs. Obviously, you have to choose the syntax. So I already mentioned external and internal DSLs. So with an external DSL, you're pretty free in defining your syntax, because some parser is doing it, and as long as it's parsable somehow, you can create whatever you want. But with Kotlin, we are obviously limited in what we can do to create a DSL, but there's still some divergent approaches how you could do something, and you have to think carefully what is better in your case. And for example, how do you get the data that the client needs to pass to your overall system? The last part, choosing the proper vocabulary, is pretty easy in my opinion, because you have this, it's a domain-specific language, and as such you have the language of the domain. And for example, with Anko, which is setting up a user interface, you have all these user interface elements. So a text view, for example, should be named text view and something like that. And you shouldn't refrain from that. But there's an example, for example, where Anko did deviate from the normal naming. So we have this linear layout, and we have this orientation vertical and orientation horizontal, and there's also an example of something that an API that went wrong, because the default is horizontal, and we need vertical nearly all the time. And so you have to think that you have to add the vertical, the Android orientation equals vertical in your XML file. With Anko, though, you don't have linear layout, you have vertical layout and horizontal layout instead. So they named it, they chose to deviate from the normal naming convention and made it easier for the client by this. So that's a good example for where you might want to deviate. So all boils down to that. Don't be clever, be intuitive, and make it easy for the client. So now to the second part of the talk, which is how do we achieve a DSL in Kotlin? Which language constructs do we have to actually make it happen? And I'm going to show some samples here from existing libraries, and where we first see what they've done, and afterwards what you can do with the library like that, and afterwards how they've done that. So in this case, it's mock. It's a library to create mock objects in tests. And so here we say whenever the view set remote vehicles is going to be called, it should just run. This means it doesn't return anything, but I want to ensure that this method is going to be called. So, and what we're interested in right now is this just runs, and especially this just part. And what we see here is that just is an infix method. So when we go back here, we had this space, just space runs. And this is just an infix method in Kotlin that allows you to do that. So whenever you have a method that takes one argument, then you can make it an infix method so that you can write it differently. So without it being an infix method, you would have to write it like that. So that's the first concept, infix calls that we've seen so far. Now back to the same example. We're again interested in just rounds, but in this case we're interested in rounds. And it turns out that it's just a simple object here, an object that doesn't do anything. And we even have a type alias, because normally runs, the objects should be written with a capital letter, or start with a capital letter, and to make it more logically readable, they have this type alias with a lowercase letter. So, and why are they creating this? Because this infix function that we have just seen needs an argument. And so to make this work, they've just created an empty object. So this is of course something where you have to be very, very careful. Don't create tons of empty objects just to make nice syntax. So if you go overboard with it, the user is bound to get confused. But if you do it rarely, like in this case mock does, then I think it's justified. But it's something you have to be careful with, and that you really have to think about, is this really something that is adding value, or is it just adding clutter? In my opinion, in this case, it adds value, but it's really a tight run. So we have empty objects and type aliases with that. Now let's return to Kotlin test. So that this is what overall should spec looks like. So you have this class, you have within the init block, you have all your test methods. This of course is a bit weird, but well, so be it. And now I'm interested in this part here, this should part, and especially in this what follows here, and it's a trailing lambda, and we use this in Kotlin all the time, probably, so this most likely is the thing that's most common to all of you. But without trailing lambda, we would have to write it like that. So we have a comma for the and have to pass in the functional type as the second argument to our thing, and then we have to close the parentheses after the lambda, which in my opinion, well, it's not that bad, but if we really want to make this nested structure of tests that I've shown you initially, then this type would really look weird. And that is why at least Kotlin and Swift as well have trailing lambdas, and probably other languages that I don't know have them as well. So with this, you can write it like that. And this is, that's really nothing special. The main point here is that the functional type has to be the last argument of of your function. So you have a function that takes another functional type, and if this functional type is the last argument of the other function, then you can write it as a trailing lambda. Lots of functions. So trailing lambdas is something that's important in the context of DSLs, but it's something that we really see all the time with Kotlin. Let's return to this example, and there's a different way to write specs. If you've seen, there was previously it was a should spec, now it's a string spec, and it only differs in that you put the code completely in a string, and now it looks a bit weird. At least to me initially it looked weird because we have this object, a string, and we're passing a function to an object, which looks, well, coming from Java, we weren't using much functions anyway, but this is a bit strange, in my opinion. But it turns out that it's just something that the language designer of Kotlin intended to achieve. And they have this special convention that whenever you name a method invoke, or whenever your class has a method invoke, or multiple methods invokes, you can, just pass something in. You can more or less invoke the object that you have with the fitting arguments then. And this allows us to write it like this. So we have a string, and we pass this lambda, not directly to the string, but to this invoke method. And in this case, the invoke method is also an extension function on string. Another thing coming from Java that is a bit weird, because in Java strings are final and you cannot inherit from them, but you can still write extension functions. And then, first of all, this is Kotlin string, but even if it were a Java lang string, it would still work, because extension functions are just static functions where you pass the object as the first argument. So they extended string by that. So we've seen now extension functions and conventions as additional concepts. Now I have to drink something, sorry.
Speak up a little bit. Speak up. Just speak up.
Too loud. Okay. So here we have another example of Kotlin X.html. This is a library that allows you to return HTML to your clients. Say you're doing a backend development and want to return HTML, you can use this library. And it's just creating an HTML document with a body, a div, and some text within the div. And to add the text, they have chosen to use this approach with this plus and then the text following that. So this is making use of a special operator, in this case the unary plus. And this unary, so there are different operators that you can use in Kotlin that you can override. It's a limited set of operators that you can override, and unary plus is one, so where you have to put the plus in front. Not would be another one where the operator is in front of the argument, and others are between the different arguments. For example, plus is between multiple arguments. Or behind them, for example, inc, if you want to use plus plus. So, and that's what they used here. Let's go back here. So I mentioned you have to think about how to pass data to the overall structure, and that is one approach how you could do that. I'm not sure. In some cases, I'm not sure if it's working well with HTML, but in some cases, it's better if you would put the text directly here. In this case, it wouldn't work because you could have a div, then you could have this plus some text. You could have another div within that, for example, and then again plus with some text. There you have to do it like that. But for example, if you have looked at Jetpack Compose, and when they have text fields or whatever, I'm not sure how they are named there, at least they pass the text then directly on the object by using parentheses, putting the text in there. So that's something where you have to consider what is working better in which case. So operator overloading is the concept that you've seen here. So you've seen this example of coin initially already. Now I want to see, or want to go into this part here, what this module is. And well, obviously it's a trailing lambda, yeah. But it's something special because this is also what is done here is that a module is created. So at the end, something new comes out of it, and we are not passing anything in, apart from within the trailing lambda. So where actually is the object created? And that is, this one here is not a normal trailing lambda, but it's a trailing lambda with a receiver. Also something that is very common within Kotlin, and it's especially common within DSLs. There you're using it all the time to create objects. And this is, okay, so first, this is the argument of the functional type for the module function, and it's a type alias, and the type alias is defined at the top. And if you have a close look at it, it looks like an extension function because there's this module dot, and then there are these parentheses. I buy it a bit weird because this extension function doesn't have any name. So what happens here is that you can really think of it like an extension function, and the name is actually the name of the argument. So in this case, module declaration. And as you can see here, that's how they're using it nowadays, where they create the module here and then call this with module. What they initially did before they changed to this style was something like this, even shorter because they directly had this equals at the end here. But they created the object called apply and then called the module declaration. But since this is an extension function, when you call this, the trailing lambda is not getting a normal it parameter, but it's getting an object of type module in this case, because it's an extension function or module. So to make this concept, because this is something at least I again stumbled upon initially, the difference between a normal trailing lambda and a trailing lambda with a receiver. We have these two standard extension functions here of the Kotlin library. So also is an extension function for every type, and apply is also an extension function for every type. And they work slightly different. At the top you can see, so both are working on a string, and on the top you see if you want to access the string within the lambda, you have to use it. So this is a normal trailing lambda, no lambda with a receiver. At the bottom, if you want to access the string, you're accessing it with this. So this is a trailing lambda with a receiver. And if you look at the definitions in the standard library of those, they look more or less like this, slightly different, but more or less like this. And you see the differences here. Here you have a function that takes an argument of the same type, and in this case you have a function that is an extension of this type. So that's all the difference there is to these both. And luckily, our favorite IDE, Android Studio and also IntelliJ, helps us in showing us with which type we're dealing with in the Lambda. So I'm not sure if the Eclipse plugin also does support this, but at least it works nicely in Android Studio and in IntelliJ. So, and this is a more complex example, and you can see this also Enco is using loads of lambdas with receiver. There you also have this, and so all of these are lambdas with receivers. So that was probably the most weird concept, in my opinion at least. For me it was the most weird concept. You might differ, of course. Now, one last concept I want to show you, and that is we have a hierarchy of things here, and we need to limit it. For example, a text view doesn't allow to nest another text view within it. But without any special consideration, there would be nothing that would prevent you from doing so. And in Kotlin 1.0, you really could do this. You could write a text view within that, and it would work. So it would compile, but it would work weirdly. So, and what happens is there's that the text view would use the outer. If here were another text view, it would use the outer this to access the object, which of course would cause all kind of trouble. And to prevent that, with Kotlin 1.1, they introduced this DSL marker interface. And whenever you use this on an argument, then this scope is limited. And you can only use this without any special thing for as long as there is no other DSL marker in closer scope. So when nesting something, in this example, for example, so this of constraint layout is no longer accessible from here for example, for the text view thing, because this is limited to the next scope, which in this case is text view. So, and this is really important, and this was a worthwhile addition to Kotlin, which made DSL less error prone, let's put it like that, because as I mentioned, try to make it as hard for your user to misuse your API. And before that, it was really easy to misuse your API. And with that, they put a stop to that misuse. Okay. So that was the last concept. So back a bit to designing DSLs. Because from what you've seen now, we can discuss some other few concepts that weren't discussable initially, in my opinion. The first is you should consider deviating from naming conventions. This just runs example was a slide deviating from naming conventions, and they did it with a type alias. But there are other things or other DSLs that do it more glaringly. For example, if you happen to use Spring for backend development, I'm not sure if any backend developers are in here, they have this routing library and a DSL for that as well. And so any incoming request could be obviously of any HTTP, could be of any type of HTTP method. So HTTP post, HTTP get, or whatever. And these HTTP methods are normally written all uppercase. So the people from Spring decided to make these methods all uppercase as well. So when you want your router to react to GET methods only, then you would write GET in all uppercase, which is really a weird thing if you look at the name of the function, but is the right thing when you put the client at the heart of your observations. And so when you look at a routing definition in Spring, it's really obvious. So, okay, this works for put and this works for gets only, and you'll see it right away. So you should consider deviating if it makes things more easier for the client. And as per usual, and I've mentioned it initially already, don't go overboard because, well, we have all these nice concepts and then we can deviate from naming conventions and we can create empty objects and whatnot. And if you combine everything, it's bound to be a great API, isn't it? No, it's not. If you combine it weirdly, it's not a great API. Just really consider doing only those things that really are important. A guy in Budapest has written this repository, and so first of all there's this README file, and this README file also implements all the discussions on this GitHub page, let's put it like that. And he discusses different approaches and also the pros and cons, and I really recommend, it's not a long read, to read this and to have a look at the samples. So if we use the concepts that I've just mentioned, now when is something a DSL and when not? Well, it's not really that important. If it's really a DSL, the important thing is, does it work really well for your client? So I've read a book, I think it was about API design in Java, and the author there mentioned that every fluent interface would be a DSL. In my opinion, no, that's not true. We have a fluent interface for String Builder, for example, and String Builder is missing the domain, in my opinion, and the language is missing everything of a DSL. So just because it's a fluent interface, it's not necessarily an DSL. So, but String Builder is a useful class in Java. You can use it in Kotlin as well, obviously. And as such, it's not really important if it's a DSL or not. It works. The same, some of these Kotlin extensions, they work on all Android Kotlin extensions. They work on all kind of different things in Android. And so they are also not concentrating on one domain, but on plenty of different domains, and are providing nice extensions that we really want to use. But this is also not a DSL, even though it makes use of lambdas with receivers and trailing lambdas with receivers and whatnot. So it's using the concepts, but in my opinion, it's not really in the DSL. But whether or not, this is not the important part. All of these are easy to use, and that's the important part. But in my opinion, it all boils down to that. Without a domain, you have no DSL, and without a proper language, you also have no DSL. So another question you have to consider is it worth creating a DSL? Because, let's go back there. Of course, it's work. It's additional work to what you have to do anyway, and all the thinking about it is another thing that takes time. So you really have to justify it and be able to justify it. So again, there are two sides to it. First of all, as a client, if any API provides a DSL for your specific problem, in my opinion, yes, you should use it. So if I'm looking for a library and there are two libraries that are doing more or less the same, and then one has a DSL, the other not, and both fulfill my needs, otherwise I would choose the one with the DSL if the DSL is nicely designed, obviously. As a provider, things are a bit different. It depends on what you're doing and how often the client is using it, and how much easier the life of your client is going to be by using your DSL versus using other means of creating stuff, for example. And as I mentioned, since I would use a library with a DSL, if you happen to write a library that you want to publish on GitHub and you hope plenty of people are going to use this, and this library, the domain of this library lends itself nicely to using a DSL, then by all means, in my opinion, you should do so. But if it's an in-house project, it really depends on how often you think that your stuff is going to be called, and how complicated it would be without a DSL. And then you have to decide, okay, it would add value to my colleagues or to my later self, if I look at it in half of a year's time, for example, and decide then. I have no hard rule for you here, but as usual, you have to think about that. So, the main benefit of DSLs is that they make the intention of the code obvious. They are made up of simple concepts that we use in Kotlin all the time. They have to be designed, and while you design it, you should put the client usage front and center, always have the client in mind, and of course they must be worth it. You must justify it to your boss or to your client or whatever. So with that, we come to Slido and whatever. So any questions?
Any questions first from the audience? Before we switch to Slido?
What domain do you think specifically benefits from using this kind of domain-specific languages?
I think Kotlin DSLs are especially useful if you create a hierarchy of objects. For example, a user interface hierarchy, or for the Google Assistant, an answer hierarchy, depending on the intents that are coming in, or something like this. With Kotlin tests, for example, this was also a hierarchy of test cases. So because the way most DSLs are structured in Kotlin, they lend itself nicely to hierarchical stuff. Any other question? Or David?
Another question? So the question from Slido is, what project did you personally use DSL for?
Where's created myself one for? Or?
If you created some library or something where you like use it?
I didn't yet create a library where I use it, but I had a Google Assistant project where I created the backend not with JavaScript but with Kotlin, and for the things needed there, I created my own DSL, which only I used then. It's not published because it's full of glaring omissions, because if you if I would want to publish it, I would have to deal with all the other cases that are not relevant for my assistant action, but are relevant for all the other actions, and that's why I didn't publish it. Okay, any
more live questions?
I think someone over here? No? Okay, I'm mistaken.
I have a question about the builders being in the Lambda, like when I fill just the property.
Pardon me, can you speak a bit louder?
Does it work?
Speak out.
Okay. I have a question about the Lambda builders. When you actually fill the properties, like property with something, blah, 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 in the Lambda, if it's possible to enforce the requirement, like filling the property
Yes, there is a compile time check, because there would be a compile time check.
Time check, but you will not have a compile time check.
You have, because it's normal Kotlin code, and if you expect an argument within the I think you mentioned the function then would take a normal argument, and if the argument is required and you do not use it, then it's a compile time problem, and the user will know right away.
But if you have like many properties to fill which are required, you need to all put that into the arguments, and it gets a little bit weird. I think.
If you have many arguments that are needed there, I think it's probably not, it might be a case that it's not either a good fit for a DSL, that's one of the cases, or that you should try to fill these arguments somewhere else, for example within the trailing lambda, that you require them there. But this can be a problem if, for example, you expect that a certain child is called within your trailing lambda. That's something that you cannot, at least not that I'm aware of, cannot enforce.
I was just thinking maybe if you know the contracts API, there's no way to enforce this using that.
I'm not familiar with that. I know that that it exists, but I haven't looked into it. So this might be a way to enforce actually this. Yeah, could be.
More questions? Okay, no questions. So thank you, Wolfram.
Yeah.
A 5-minute break before we prepare the next speaker. So take some drink, food.
Radek mě poslouchá. Petr Kubeš.
We'll start with the next talk. If you can please sit. So let me introduce our second speaker. It's Petr Kubeš from Uplifting. Petr, it's yours.
Okay, welcome to my talk about coroutines, the confusing parts. First of all, I would like to do a quick survey. Who is using coroutines and is like an expert on coroutines? And okay. Who is not using coroutines at all, have never seen them, never used them? Okay, so that's perfect, because this talk is for people who just started using coroutines because it's a cool new thing and kind of forgot about reading the documentation and just used global scope.launch and everything put in there, and that was it. So let's get into it. For the one guy who does not know what coroutines are, so here is quick comparison. Imagine that you are like, I don't know, downloading something, then processing it, and then just doing something else. So what you would like to do is show loading on the main thread, for example, in Android application. Then you would download stuff, then you would process stuff, both on some background thread, and then you show loading, hide loading. And on the right, you can see how would you do it in coroutines. Here you would see the classic callback hell. Who has seen the callback hell sometimes? Just a few people, or almost everyone. Or you could learn RxJava or something like that. This code might be wrong. I have never used RxJava actually, so I just guessed. So that's the reason why I would like to learn coroutines, because it looks nicer and you will have fewer bugs and nicer code. When you open the coroutines, some basic tutorial, you will see, okay, so coroutines are like lightweight threads. That is kind of confusing, because one would think that they would put coroutines next to threads, like you have threads and you have coroutines. It's the same thing. But it's actually not. Coroutines are built on top of threads, which are implemented in the operating system, and which uses cores like in your CPU. And coroutines actually are a language feature, not operating system does not know anything about coroutines. What the heck are scopes? Well, when you are launching a coroutine, you have to launch it in a scope. You cannot just write launch anywhere in the fun main, and then you would like to launch coroutine, and that doesn't work. You need some kind of scope, and that's because launch is defined on scope. If you look in the definition, it's an extension function. And what it takes is some context and some block and some start, returns the job, whatever. So how would you launch a coroutine? Well, first you have to create a scope by using coroutine scope, and you put some context there, which is also confusing, because how you create a context, you put some jobs and you plus it with dispatchers.default. Like this is if you go through the basic tutorial, this is what you will see, and that's a lot of confusing stuff. Why you need creating context by plussing some things, and then you create coroutine scope by putting context into it, and then you can call scope.launch, and you can finally launch a coroutine. So I just, my first intuition was just copy paste that and use coroutines, and that's what I did until making this talk. So what is the coroutine scope? Well, coroutine scope is something that has coroutine context in it, and that's it. Nothing special. And the nice thing is that, for example, you have some Android activity and you implement coroutine scope, and then the activity has context, and that's it. And then you can call the launch in activity, and you can launch coroutines everywhere. Well then, what are contexts? Context is, like in the basic tutorial, you will see, well, we create context by typing job plus dispatchers, and you're like, what? Plus sync dispatchers with jobs, what is that? Well, it turns out that job by itself could be coroutine context, or dispatcher could be coroutine context also. And if we look in the source code of coroutines, it's actually very nice source code. It's commented everywhere. You can click through it in the ID. You will see that job extends some coroutine context.element, which has some key. And then coroutine dispatcher also implements some element. And it turns out, whoa. Okay, we are done. Let's use my keyboard. So both dispatchers and jobs are contexts. Here are the implementation, and it turns out there is a few more things that can be context. It's coroutine name, something called thread local, and something called coroutine exception handler. I will not talk about these in this talk, but you can create a coroutine context by plussing all of these together, and that's coroutine context. So what is it? Like, why do you are plussing some context together to create a context? Well, it's just a different way of creating a set. It's nothing more than a set of these things, and they together form a context, which is a set, and you can access these elements in the set by using the parentheses. So recap, scope is something that has a context, and context is a set of elements like job, dispatcher, coroutine name, and a few more. Okay, then there are the jobs and deferred, I think. And what are these? Well, if we look at this piece of code, we will see that you launch a coroutine in run blocking block, and then it prints I run on this thread, and then you launch a coroutine on different thread, and it runs on different thread, and then there is another print, and you will see that it actually, the block in coroutine will run last. So maybe you would not expect that. So let's see how we can fix that. The coroutine launch returns a job, as we've seen before. So what you could do is that you assign, or you get the job, and what you see is that the job is a different kind of job than the job, the run blocking. It has different jobs, so some kind of job is created there. Oh, I was talking about something else, and then I just got lost, so I will talk. I got confused in my slides because they are similar. What I want to say here is that you have coroutine context in the run blocking block, and then you have another coroutine context in the launch block. And these contexts are kind of created from one another. So if we see this graphics, which I stole from some Medium post, and we will see that if we are on in the parent scope, in the run blocking, that would be like this, and we call launch and put some context here. It will take the scope or context of the run blocking block, and it will put the additional context to it, and then you have the parent context, and you again plus it with some new job, and this new job is a new job created in the launch, but this child job has a parent, and the parent is the job in the run blocking block. Might be a little confusing. Yeah, this is just a demonstration of the different jobs. Now, what can we do with a job? Like, what we can do, two main things. We can wait for the job to finish, or we can cancel the job. So here's an example. We it was here. Here is the example. And if you want to first print this one, then print this one on different thread, and then wait for the job, we call job join, and that's what jobs are for. Jobs is that they see the parent like they are connected to the parent. If we create a coroutine inside, if you call launch inside another launch, and then we wait for the parent job, we will automatically wait for the child jobs also. So we can just start one coroutine, start another coroutine, and then we wait for the parent, and it will finish after the last child coroutine finishes. We can also cancel jobs, and one would think that maybe, just maybe, you could cancel a job like immediately, like force the cancellation. Like you can cancel thread, so you might be able to cancel a coroutine, but that's not true. If you run an infinite loop inside like a launch block and you cancel the job, it will not cancel. The reason is that you have to help it with the cancellation. So what you do is that you use this isActive variable, and this will finish properly. Again, it works with the parent, so you can cancel the parent, and all the coroutines inside the parent will be cancelled also. You can also break coroutines. This is completely valid code, like it will compile and run. But the problem with this is that you broke the hierarchy this, and then the child job will not have parent, or the parent will be a different job, and then when you cancel a parent, the child will not get cancelled. So this way you can break the coroutine, because you pass a wrong job into the context. Now, what is deferred? It's something like a job. It inherits a job, but the difference is it has some kind of type. You can use it in this way. You just have some task. You call async. Async is something like launch, but just returns deferred instead of a job. And then you call task await, and you will get the variable that you returned from the async function. You can do tricks with that. You have a list of images to download all at once. So you can just call images, and then you async all of them in a map, and then you map again and await the items, and it will download all of them synchronously. Now, another confusing thing about coroutines is the dispatchers. As we've seen in the first example, there is some dispatcher.default, which the block to run on a different thread called default dispatcher work1. And there, yeah, this is just a side note. I will be using with context instead of launch because when I am calling this code, I have to call the join to run this, then this, then this, and you can do it quicker and with calling with context like this. And now it again run first this one, then this one, then this one. The dispatchers is dispatchers.default. Dispatchers.io and .main are like the main dispatchers you will probably use in your code. The default dispatcher, it's supposed to be, or in the documentation it says that it's the same, it's using a thread pool which uses the same number of threads as you have cores. Why would you use dispatchers.default? Well, for example, for some CPU intensive computations, because it does not make sense to have more than the threads you have on your computer for computations. Like creating more threads would be wasteful. On the other hand, dispatchers.io use more threads than the default, because when you are doing I/O, the threads are like suspended on the level of the operating system, so you would just there's no reason to not have more than like the number of threads you have on your computer. And then there is dispatcher.main, which allows you to run code on your main thread, but there is an asterisk because it works only in application libraries which have main loop. For example, Android, there is some loop that's running over and over, and when you put it in dispatchers.main, it means that the code is executed by that loop. Like, you cannot use dispatchers.main in a pure Kotlin file. You cannot create fun main and then run dispatchers.io because it's not dispatchers.main because it's not implemented. And then there is some dispatchers.unconfined, which is confusing, and it says in the documentation that should not be used like generally. And it's just determined by the launcher thread and then the code inside and so on. So I would not care too much about dispatchers.unconfined. I implement my own dispatcher. If you have dispatcher and you implement coroutine dispatcher, you have to override, and you can override dispatch function, and that's the only function that's there. And you will get some coroutine context and a block, and then you can just run the block, and that's it. And it will kind of work, but it doesn't really work. It will. This kind of dispatcher I created will work for almost all functions. Just the delay, it broke, and it did not tell me how to fix it, so I did not. But dispatcher is just a wrapper that executes a block on some thread or something like that, like a pool of threads. Nothing really complicated. I tried to test the on the Kotlin website that dispatchers.default has the same number of threads as it claims that this MacBook has 24 threads, which I don't think is right. It should be 12, but maybe there is some reason for that. But as we can see, dispatchers.default, I started executing a lot of coroutines, and it started executing a lot of them, and then it was waiting for some of them to finish, and then it started executing the 25th one. When I switched it to dispatchers.io, all of them started right away. This is just a side note for newbies into coroutines. If you run this and then you do launch dispatchers main and then you do something after it, it will print first this one, then this one, then this one. Because as I said before, dispatchers main is implemented using the event loop of Android. It's not like it runs from top to bottom. And questions, live code. I don't really want to do live code, but if you have some interesting questions, I could show you something. I have. Should I answer first these or?
It's up to you.
Okay, so I will start with these. For what are you using coroutines in uplifting? Well, we had one project, I think, in which we first were using callbacks, and then I implemented it using coroutines to make the code nicer. And then we started a new project a few weeks ago, and I'm using coroutines for everything there. And it's very nice to have database implemented using coroutines, then retrofit using coroutines, everything using coroutines, and it just creates very compact, nice code. Confusion number 3, why is there thread sleep? This would stop the thread and won't allow execution of other coroutine. What about delay? Yeah, I used the thread sleep intentionally because thread sleep really sleeps the thread, and it's not fake sleeping like delay. Everyone knows what thread sleep does, but delay could cause some confusion, and thread sleep simulates like heavy I/O work, or it could simulate like computation or something like that. And 12 physical cores, 24 logical threads due to Intel hyper-threading technology. Well, the problem is that the MacBook has 6 physical cores and 12 threads due to hyper-threading. So, and any more questions?
Have you considered using reactive extensions over coroutines?
No.
Have you choose the coroutines? Reactive extensions, Rx, Java, Rx.
Yeah, I mentioned it in the first slide. We had one project in which we have used it, but it's. I think it's at the end more confusing for a lot of people than coroutines, because the library is much bigger and you have much more classes to learn, and coroutines in the end even produce shorter code, so that's the reason.
Okay, thanks.
No questions? Okay, thanks. So now the informal part starts. Please have a beer with us. JetBrains and Google is sponsoring it. And let's do some networking.